All right. Today we're talking about word problems, good old-fashioned word problems, and we're going to figure out how we can tell if our word problem is in the ballpark of being right or not. This last question right here, before we even get to the reading, why is your answer reasonable, is something that your children will see tonight for their homework and on their test on Wednesday. But let's go and jump right into the question first. It says the beach is 7 1/3 miles from Joanna's house. She walks part of the way. Then she takes the bus the remaining 5 7/10 miles. How far did she walk? So we have a couple of pieces of information we need to pull out. We know that the beach is 7 1/3 miles from her house. We know that she walked, but we don't know how long she walked, so she just walked part of the way. We also know that she took the rest of the time, the rest of the miles, and went on the bus. So that was 5 7/10 miles. Those are our three very important pieces of information. The next important part is to figure out what we need to do with this information. In this case, we have a choice between either adding or subtracting. In this case, we will want to subtract because we know the total distance, but we don't know how far she walked. So this is where the why is your answer reasonable come into play. We're going to take our two numbers that we do know. We have 7 1/3. If we take 7 1/3, we round that to 7 because 7 1/3 is close to the number 7. 5 7/10 is actually close to 5 1/2. When we subtract those from each other, because we realize that our problem asks us to subtract, we should get somewhere around the area of 1 1/2 for our answer. Now, this is not saying that 1 1/2 is the answer, but this is the reason why this will tell us a reasonable ballpark for our answer. Alright, so then we go to the actual problem. 7 1/3 minus 5 7/10. And let me back out just a little bit. There we go. First things first, we see that we have two different denominators, so we have to find our LCM. So we have to figure out our LCM, which is 30. We're going to bring our whole numbers. And let me make this 5 a little bit bigger. So now we have, how did we get from 1/3 to 30, which is times 10. So we know 1 times 10 is 10. How did we get from 7/10 to something over 30? This was times 3. Our multiplier is 3. 7 times 3 is 21. From here we realize, just like before, we have to look at our denominators and our numerators now. And we see that our numerator at the top is smaller than our numerator at the bottom, so therefore we have to borrow. So this 7 now turns into a 6. We bring over 30 30s, which gives us a grand total of 6 and 40 over 30. And then we just bring over our 5 and 21 over 30. Now we subtract since we have our bigger fraction at the top. So 40 minus 21 equals 19, and that's 19 over 30 because we don't subtract our denominators. And we have 6 minus 5, which gives us 1. So now let's look at our answer. We have 1 and 19/30. To check for reasonableness, we look at our answer here, 1 and 1/2. Now, half of 30 is 15. So 19 is just over that halfway mark. So 1 and 19/30 is a reasonable answer. Now, if we did something backwards and we actually added, we will find out that our answer will be somewhere closer to around 13 1/2. And that's not close to this reasonable answer of 1 and 1/2. So what this asks us to do is to check our answer to make sure it's right, and now we have a reasoning behind how we know our answer is right.